A routine drive along a divided highway, under and over numerous bridges. How are they constructed? How are they kept safe? Let's find out.
Hello everybody, welcome back to this channel. So today I am in a town by the name of Arnprior, which is about half an hour west of Ottawa. I am on a bridge over the Madawaska River, which you can see in the background now. And what I'm going to be doing today is to talk to an engineer who is in charge of refurbishing this bridge that you see behind me. So before I get to the interview, I will introduce my guests. So as usual, I have Bob Radinovich here, the chair of the Algonquin Chapter. And as you can see, he's playing around with our new toy. So during the last couple of videos, we got feedback from some of you viewers that we should try and kick things up a notch by buying a second camera so that we can change the scenes a little bit. So we convinced PEO to give us some funding, and you can see Bob playing around with the new GoPro Hero Black 8. I hope I got the name right. Anyway, so that's Bob, and then I get to introduce to you our guests for the day. And there they are. On my left, I have Dave Unrao. He's the vice chair of the Algonquin Chapter. And on my right, I have our guest of honor, who is the engineer who is in charge of the project here. And I will ask her to introduce herself and give us a little bit of background herself.
Hi, I'm Julia Marson. I work for WSP and I'm the manager of bridges for Ottawa and the Kingston region. I did my undergraduate degree in civil engineering at the University of Western. I then followed up with a master's in structural engineering at the University of Ottawa. I stayed in Ottawa and started working for a small bridge engineering firm called Harmer Podolak Engineering. It was a great experience to be in a small bridge engineering firm. We did everything. We did inspections, we did design, bridges, retaining walls, dams. So at the PEO, I actually received my PEng 1 year after starting work, because 1 year for my master's, 1 year for my experience that I had gained, and then continued learning. Really before I kept using my stamp. So one thing that I'd like to say is I kind of like the 4 years with my staff right now, getting much more experience before they take that leap in using their stamp. We continued working until we were acquired by Genevar, which was at that point a multidisciplinary firm in Quebec. We were one of the first acquisitions in Ontario. Following that, they acquired right across Ontario and into the West. It was a great opportunity as a bridge engineer to have a multidisciplinary firm behind me. I now had my roadway engineers, my electrical engineers, my environmental engineers, my hydrology engineers, all within my own team, instead of always having to go out to be a sub to someone else. Through this time, I worked with a multitude of different clients, both at the municipal level, County of Renfrew, City of Ottawa, worked provincially for the MTO, Ontario Parks, M&R, worked federally for Public Works, for the National Capital Commission, as well as Parks Canada. Through that all, I then became manager of our bridge group in Ottawa. And then through more acquisitions, we acquired WSP, changed our name, rebranded to be WSP, and then we also acquired MMM, another Ontario consulting firm. So now I'm the manager of our bridge group in Ottawa and Kingston, with a total of 50 employees working with me on bridge engineering, and such as this bridge rehabilitation that we have here across the Madawaska River in Arnprior.
Thank you, Julia. I wondered if you could maybe tell us a little bit about the bridge and what's going on during this construction project.
The Madawaska River Bridge is 215 meters long. It's a 4-lane bridge right in the heart of the city of Arnprior. It has sidewalks on both sides, and it was open to traffic in 1976. So it has 5 spans across the Madawaska River. We have concrete piers in the water, 2 concrete abutments on either end. We have 8 precast girders supporting the bridge, a concrete deck on top, waterproof and paved.
Now, Julia, why would you do a refurbishment versus an overall replacement for this structure?
Correct. So we currently design all of our bridges to the Canadian Highway Bridge Design Code. Currently, if we were to design a new bridge, we design it to 75 to 100 years. Existing bridges that were designed before our Canadian Bridge Design Code would have been designed to the Ontario Bridge Design Code with a rough lifespan between 60 and 75 years. However, the only way we can get our bridges to have a lifespan of 75 years is to repair and rehabilitate them throughout that 75-year lifespan. So what we need to do is do minor and major rehabilitations on our bridges so that we can keep that service life, because as you can imagine, the cost to replace a bridge as opposed to just repairing it is quite different.
If I understand correctly, the bridge itself is in the town of Arnprior, but it's under the jurisdiction of the county of Renfrew, and that's who's doing the project?
That's correct. A lot of the bridges were originally, this bridge in particular was originally built by the province, the MTO. It has an MTO site number. And then the MTO downgraded down to our major municipalities, which being the county of Renfrew. So the larger municipalities now own most of our bridges, rather than some of our very small towns.
Now, can you explain some of the major elements that is being refurbished and the importance of the different elements, like the bearings and the expansion joints and those type of elements within the bridge?
Absolutely. So like I said, the bridge has a service life of 75 years, but not all components have that same service life. So we have replaced some of the bearings on this structure. In order to replace them, we needed to jack the bridge, restrain it, so that we were able to replace the bearings. The expansion joints have also been replaced. On this bridge, we have expansion at either end. So for a 215-meter bridge, there is a lot of expansion between that, on that bridge. We have 2 different types of joints. The joints right behind us here will accommodate a small amount of movement, and the joints at the other end are called finger joints, and they're able to accommodate much larger expansion. What else we've done is the top of the concrete surface, even though we have waterproofing on the deck, it still gets deteriorated with the water and the salt. So we've removed the very top surface of the concrete, and we've reinforced and replaced that. Our sidewalks as well had a lot of deterioration, and we've overlaid the sidewalks. We've also replaced all of the waterproofing, and we'll be paving the bridge as well.
Thank you for explaining the different components. Now, in regards to the inspection, or how you know which components are required, is there some regular inspection that is done for bridges, and is there special equipment that you use?
So every 2 years in the province of Ontario, we do an OSIM, Ontario Structural Inspection, manual inspection. So this inspects the entire bridge, the top, the bottom, whatever we can see. And that's done every 2 years. So that's going to find out any defects. It's going to make sure that we know the condition of the bridge and any maintenance that might be needed. On some of our bridges, every 10 to 15 years, we'll do an enhanced OSIM, at which point we do hands-on inspection, and we try to get to all components of the bridge with hands. So on this one, we would use a bridge inspection unit that would have a bucket that would go underneath the bridge, and we'd be able to look at the underside, look at the girders, look at the underside of the deck. So that was done as part of the inspection in order to get ready for our rehabilitation of this bridge. So we knew exactly what we wanted to repair.
Now, in regards to the concrete deck, is that something that is inspected once the asphalt is removed, or can you do some type of inspection of the actual concrete deck before the asphalt's removed?
Yes, so one of the other inspection programs that we have, and we usually do before rehabilitation, such as this one, is a deck condition survey. So if we have an exposed concrete deck, which we do on some of our bridges, that one's easy. We take a chain and we can drag it. We can hear whether or not it's delaminated, which normally means that we've got water in the concrete deck, might be getting to our reinforcing. But when we have asphalt, not quite as easy. So what we do in that case is we'll cut out a large piece of asphalt, we'll remove it so that we can take a look at the waterproofing, take a look at the concrete deck. We can also take concrete cores. When we take the core, we're able to examine what the asphalt looks like and the thickness of the asphalt, the waterproofing, how it's bonded to the concrete, as well as the concrete itself. When we do that, we're also able to see the condition of the reinforcing that we might have cut through. And we can also do corrosion potential, which is taking small drill holes in the asphalt, and we're able to find out how we measure the corrosive potential on the bridge deck, and therefore we can tell how much chlorides and deterioration we might find in the top of the concrete deck. And then as well, when we start a rehab such as this and we remove the asphalt and the waterproofing, we actually have a much better view of the concrete. But those other inspection methods are able to predict and estimate how much we think that we will need to replace. So here we have almost a before and after look at our new expansion joint. We're standing on the before, which is in construction. We can see that the reinforcing that's coming from the deck, as well as from our approach slab. All of this clear stone will be removed once we have our expansion joint. But what it looks like when we're done is on this side with the tractor. So we have the deck on the right-hand side, the approach slab on the left-hand side. So the approach slab is connected essentially to our ground. The bridge side is on our girders. We'll move and expand more. So what we have is there's a gap between the two steel armorings, and there's a rubber seal in there. And that rubber seal will expand and contract based on the temperature that the bridge goes through.
Now, Julia, in regards to the expansion joint, so we're doing this rehab and we don't want to do it very often.
Yes.
What maintenance would be required for, say, the expansion joint?
Yeah, so very limited maintenance. The only thing is cleaning. So as you can see, the dirt and grime that gets on top where we can't see the expansion joint. We just want to make sure that we're not puncturing that expansion joint material, which is the rubber seal. If we start puncturing it, then we get water down to our substructure, which causes more damage.
So you just clean it with a pressure washer?
Exactly,
Exactly.
And they do that once or twice a year.
Julia, can you explain what we're looking at right here?
Yeah, so what we have here is what's called a bearing. So the precast concrete girder sits on the bearing. The bearing sits on the concrete abutment or the bearing seat that's right underneath it. The bearings take some of that expansion when the bridge moves. So these are sliding and rotation bearings. So they'll take the longitudinal movement due to temperature, and also allow a slight rotation in the bearings.
And what are the bearings made out of?
So these bearings here, we have a concrete girder. We have a steel plate embedded in the concrete girder. We have a steel plate as part of the bearings. Then we have a stainless steel plate that allows the movement underneath a larger steel plate. And then we have an elastomeric rubber bearing underneath that steel plate.
So Julia, whenever I drive on Highway 417, it's a great explanation you made about the joints.
Yes.
I was always wondering about that steel finger-like thing,
Yes.
and then on the other side there's that double paddle two plates
Yes.
like thing. What I was always wondering was, when it comes to the design of the girders, are they simply supported or are they cantilevered, or do you know anything about that? Can you explain something about
Yeah,
that?
so these girders here are simply supported. on the pier and on the abutment. The next one will be simply supported on the two different piers, and then we do a closure pour in between. If it was steel girders, normally we keep them separate, and that we don't normally cantilever our large bridge girders. But if we had in a steel case, we might have main girders running longitudinally. We might have stringers running transversely, and those stringers would be cantilevered, supported on the main girder, and they might be cantilevered off to support our sidewalk.
The description you did about the concrete was really interesting. So actually there is some air entrained in the concrete to give it the properties that you want, basically.
That's correct. And what we want it to do, especially in Canada, is make sure that we don't have a freeze-thaw problem. We know that when water freezes, it expands, and if we get water in our concrete, in some of these air bubbles, it will expand. So we need to make sure that it's not doing that.
It's fascinating because I'm not a civil engineer by training, and to hear these things, it's really fascinating because we do take a lot for granted when we drive over these bridges, right? At 100 kilometers an hour, you have not much stopping space if something were to go wrong, and it's really fascinating to know what the preventive maintenance program looks like, and so on and so forth. It's great.
That's right, and we don't normally get to be able to see the underside of the bridge when we drive over top.
Absolutely not, and this is the first time I'm seeing something like this on the underside, actually. It's an impressive structure.
Yes.
And this is not one of the biggest bridges either, right?
No. Steel. So all of our concrete is strengthened with our steel reinforcing. So concrete's great in compression, not in tension. So the only part that we take tension out of our reinforced concrete is through our reinforcing. And the reinforcing might have a cover of, it used to have a cover of 40 to 50 millimeters. Now we're using 70 plus or minus 20. So between 50 and 90 millimeters of cover. So we have more concrete before we get to the reinforcing. One of the reasons why we had to do more work on the sidewalk is that the reinforcing was quite high to the surface. So it's just going to deteriorate faster. This one, that was one of the design challenges on this bridge. We actually have hydro and bell on this side and bell on that side and street light ducts in the parapet wall. So they were, they used to always be installed in the sidewalk, but if you're trying to think about getting those pipes in the sidewalk and then reinforcing around that to actually reinforce our concrete, there's not a whole lot of room left for the concrete. So a lot of times the pipes are high or the reinforcing is high, and that causes more deterioration in our deck. So now our standard is we actually normally hide it, we hang it from the fascia. Or some municipalities, some clients will actually bury it under the river.